Hi everyone, welcome to the video on probability. Now this is the first one that we're doing for this topic, and to start off with, what I'm going to do is I'm just going to go over some of the basics of probability. Really the questions that I do today are pretty much expected knowledge, so it's important to make sure that you know how to do these ones, and I think basically going through the first two exercises of this chapter should basically just be a revision exercise. So let's get stuck into it and go over some of these rules. So the first one is that the probability of an event is always between 0 and 1. It can't be outside of that. A probability of 0 means that it's impossible, and a probability of 1 means that it is certain. So that leads on to the next rule, which is the probability of A plus the probability of not A, or the complement of A, is equal to 1. So the sum of any probabilities should always add up to 1. Okay. This symbol here means the null set, so that's an empty set, or a set of things that has nothing inside it. And so the probability of that set is always going to be 0. We also have these symbols here, the union and the intersection symbol. So union means or, intersection means and. The way I always remembered it is that this here sort of looks like a U for union, and this here sort of looks like an A for and. Okay, and this is called the addition law of probability, and that is that the probability of A union B is equal to the probability of A plus the probability of B minus the probability of A intersection B, and we'll see how and why that is that way shortly. The next one, the probability of A intersection B is equal to 0 for mutually exclusive events, and the probability of A intersection B is equal to the probability of A times the probability of B for independent events. Now I've put these two next to each other because it's really important not to get them mixed up. So I wanted to go over what these actually are. So mutually exclusive events are two events that cannot happen at the same time. So if we're talking about rolling a die, then the outcomes of 4 and 5 would be mutually exclusive because we can't have both of them happening at the same time. And what this actually looks like on a Venn diagram is two circles which are completely separate. They do not overlap in any way, and that's why the intersection of them is equal to 0. As for independent events are those where the outcome, when one outcome happens, it doesn't affect the likelihood of the other. So, situations where that might happen is if you, say, draw a card from a deck and toss a coin. One outcome is definitely not going to affect the other there, and so they would be examples of independent events. The last one is the rule for conditional probabilities, and this line here means given, so this is the probability of A given B. So that means that we know that it's just based on the bits which are in B, and we're looking at the elements from A that are in B as well. So basically what that means is we've got the probability of A intersection B divided by the probability of B, and that is just a rule that we need to use. It can be rearranged if we need to. So those are some of the basics, and I think rules that you should be fairly familiar with already. So let's have a quick look. List the sample space for rolling a tetrahedral die and tossing a coin at the same time. Well, the symbol for the sample space is epsilon, if it's going to let me draw it. There we are. And we list the sample space as a set. So when a tetrahedral die has 4 sides, a coin has either heads or tails. So we could have one with a head, one with a tail, 2 with a head, 2 with a tail, 3 with a head, 3 with a tail, or 4 with a head, or 4 with a tail. And that is the sample space for that event. Continuing on, calculate the probability of drawing a jack or diamond from a standard deck of cards. Well, see it's saying jack or diamond. That means the probability of a jack or a diamond is equal to, now we're going to use the addition law here, so that's the probability of a jack plus the probability of a diamond. And the problem is that if we do this, we're going to count one of the jacks twice. We're going to count the jack of diamonds twice. So we need to minus the probability of having a jack and a diamond, which is essentially the jack of diamonds.